What's the difference between brightness and luminosity?
I say brightness is how it appears in the sky, and I have no idea what luminosity is.
What's the difference between brightness and luminosity?
I always thought like luminosity, right?
Yeah.
I always thought that's like glowing in the dark, almost like light is like energy given, and luminosity, it's like it makes light because of like the presence around it. I don't know. I'm really not sure actually. But what do you got?
Me? I mean, I don't know. Brightness. When I think of brightness, I think of my iPhone brightness level, you know, bringing it down. And then luminosity, I just think of the brain games online, to be honest. That's what I think, but I don't know.
Yeah.
That's about it.
That's really nice.
Mr. Madison, what you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
Okay, a simple wrong would have done just fine, but
luminosity and brightness are not the same thing. Luminosity is the total amount of radiation emitted by a star, and brightness is the total visible light only. The two things that determine the luminosity of a star are the size of the star and the temperature.
As you can see here, this diagram is showing that as the size and temperature of a star increases, the habitable zone shifts outwards. Now within the habitable zone of a star, there are certain requirements that must be met for a planet to be habitable. In order for the planet to be habitable, it must have an abundance of water, energy to conduct chemical reactions, a temperature between negative and 100 degrees Celsius, nutrients to build organisms, and an atmosphere to protect and heat the surface.
So by now we have spoken about what luminosity and habitability are in a star system. Now we are going to show how these relate to each other and how sometimes habitability can't happen due to the strong luminosity of a star. In the HR diagram, we examine a line to demonstrate the main sequence stars. Our sun falls in the middle of this diagram. As you go up this diagram to the left, you get larger main sequence stars and have a high luminosity and very high temperatures. These stars are going to struggle to have habitability. As you go down the diagram to the right, you get smaller main sequence stars. These stars will also struggle to have habitability.
News.com. Hey there, Ian. So, what exactly did the scientists discover in the Lyra constellation, and what can we learn from this?
Well, yeah, you mentioned that in particular it was one star system that actually contains two planets that are within the habitable zone of that star. Now, this system is of particular interest. It's called Kepler-62. It's of particular interest because these are the smallest planets that fall within the habitable zone of the star that's ever been discovered. Now, this star is a red dwarf star, so it's kind of different from our star. It's older, and it's smaller, and it's less bright. But these two planets actually orbit within the zone around the star that is probably just right, just the right temperature for liquid water to exist